Hey everyone! Today we're diving into something absolutely wild. The idea that US drone aircraft carriers are coming, and why this concept might really change how navies fight, project power, and think about dominance at sea. Think of it as a hybrid between sci-fi and serious defense planning. What's real? What's speculative? And what's exciting? Let's walk through the concept, the tech, the challenges, and what it could mean. Imagine a naval vessel whose primary function isn't to host piloted fighter jets, but to serve as a mothership for swarms of unmanned aircraft. A floating drone base that can launch, recover, resupply, coordinate, and control dozens or even hundreds of drones, doing missions of surveillance, strike, electronic warfare, or aerial refueling, all while being someone else's carrier wing. That's the rough idea behind these proposed US drone aircraft carriers. At present, the Navy is not building a fully autonomous, drone-only supercarrier out of thin air. What is happening is more incremental. The Navy is investing seriously in carrier-capable unmanned aircraft, known colloquially as loyal wingmen or collaborative combat aircraft CCA, and in the systems to coordinate them. Let's walk through the key features, performance implications, design elements, and what makes this so novel and risky? The core vision here is that these drone carriers would multiply reach, flexibility, and resilience. Traditional aircraft carriers are extremely costly, on the order of $10 plus billion each for the large nuclear-powered Ford-class ships. And you can only build so many. Business Insider, they require a huge crews, massive logistics, and are high-value targets. The idea is that a drone carrier with automation and fewer human requirements might be significantly cheaper, more numerous, and more expendable. One big advantage is force dispersion. Rather than putting all your eggs in a few massive carriers, you could conceivably field multiple drone carriers, spreading risk across the fleet. If one is damaged, others continue. You could mix manned and unmanned carriers in a strike group to boost sortie capacity without overburdening the traditional carriers. Another benefit, because drones can be smaller, lighter, and more modular. The supporting ship docenti need to be built with all the same constraints a full manned jet carrier would demand. You might be able to get away with shorter launch and recovery arcs, lighter arresting gear, or even different recovery methods, and perhaps smaller hulls or auxiliaries converted from existing vessels. Also, by pushing autonomy, AI, and networked operations, these systems could do more persistent surveillance, loitering, or even strike missions while lowering risk to human pilots. You offload certain risk to machines in the contested airspace envelope. So, how might one of these look technically? And how do the drones themselves operate in this system? For the drones, the Navy is already soliciting designs from major firms, Boeing, Anduril, Northrop Grumman, four-armed, carrier-capable, unmanned aircraft. These drones are intended to be modular, interoperable, interchangeable, versatile, meaning you could use them in multiple roles. Strike ISR, intelligence, surveillance, reconnaissance, electronic warfare, maybe even aerial refueling or support roles. National Security Journal. On the control side, you have a system of common control, possibly centralized or distributed, to manage swarms or flights of drones from the carrier or in conjunction with other assets. Lockheed Martin has been contracted to build such systems. An example of a stepping stone is the MQ-25 Stingray, which is a drone the Navy is preparing to field around 2025 to 2026 from traditional carriers. Its primary mission is aerial refueling, extending the range of manned aircraft, but it also has ISR capabilities. Design elements for the drone carrier could include a flight deck size 4 drones, which might use more flexible launch recovery systems, including vertical or short takeoff, landing designs, or catapults suited for unmanned systems. Hangars and maintenance bays designed for drone types rather than full-size jets. Autonomous or semi-autonomous systems for drone handling, robotic arms, automated refueling, rearming systems, redundancy in internal systems. Robust communications and data links. High bandwidth, low latency. Secure networks to control drones in contested electromagnetic environments. Redundancy in modular architectures, so that if part of the system is damaged, drones can still be controlled or Possibly hybrid man-to-man operations, the carrier might still have a small human crew for ship operations, damage control, navigation, but many functions could be automated. In short, you redesigning a ship that is less a floating airport for pilots and more an intelligent, unmanned command node and drone depot. Performance and operational considerations are where the challenges get real. It's one thing to sketch a visionary blueprint. It's another to operate it under combat stress. One of the major performance concerns is bandwidth and communications latency. To control drones, especially ones doing precision missions or operating in contested airspace, you need reliable, secure, high-speed connections. If those links drop or get jammed or spoofed, the drones could lose guidance or be manipulated. Another issue is autonomy. And drones will need to respond in real time to threats, navigation hazards, sensor inputs, and more. While AI has come a long way, machine control in chaotic adversarial environments remains a non-trivial problem. There's risk of hallucination machines making plausible-looking but incorrect decisions, or being tricked by adversary countermeasures. Damage control and resilience are also critical. When a manned ship is hit, human crews can triage, repair, reroute power, isolate damage, patch leaks. An unmanned or lightly crewed vessel has to rely on automation, redundancy, and fail-safe design to survive under attack. Logistics are another performance pillar. How many drones can be carried? How fast can they be turned around? How many spares? How much fuel? Munitions? Maintenance capacity? Spare parts? E-Tech-A. If a drone carrier becomes a bottleneck or limiting factor, its strategic utility diminishes. In contested zones, the drone carrier itself may be vulnerable. The more autonomous it is, perhaps the less protected it is in conventional defenses. It will need defensive systems, escort ships, and protective strategies because it will be a high-value node. Also, integrating with existing carrier strike groups is you'd have to coordinate airspace, control links, rules of engagement, target and logistics interactions between manned and unmanned systems. What makes these drone carriers special, or unlike anything the world has ever seen? ISNT, just a novelty, but how they could shift strategic thinking. First, they change the economics. Because drone carriers could be cheaper, you might build more of them, making power projection more distributed. Second, they shift risk from humans to machines. Third, they allow a greater reach or operational persistence. An unmanned system might loiter longer, strike deeper, or patrol more persistently. Fourth, they enable new tactical doctrines, swarm attacks, layered drone hierarchies, distributed sensing, adaptive mission planning. One especially interesting concept is turning existing amphibious or flat-top ships into drone carriers when not hosting Marines or helicopters. Some analysts argue that launching manned aircraft imposes constraints, runway length, G-tolerance, structural design that can be relaxed if you only plan to launch drones. Nonetheless, the future isn't purely unmanned. For many roles, human pilots and decision-making will remain crucial for some time. The drone carriers are more likely to become force multipliers rather than to give a concrete narrative flow for a video. Start with setting the scene. The naval warfare challenges range, cost, risk. Then introduce the concept of a drone aircraft carrier. Show how the Navy is already taking steps like contracts to build CCAs, work on common control systems to move incrementally. Then go into design features you'd expect: deck layout, automation, control systems, followed by performance caveats, communication autonomy, logistics, survivability, then balance with strategic upside. How this could let the US Navy spread force. Complicate adversary targeting, enable new operational modes, use visuals, diagrams of a drone carrier, drone flight decks, swarming drones, network diagrams, use metaphors like a floating drone hive, or aircraft carrier meets drone cloud. Drop in real examples, like MQ-25, as stepping stones, and comparisons with what other nations are doing. For example, drone-capable ships in China, Iran, Turkey, to ground it in reality. National Security Journal 4. Tone. Alternate between excitement. This is futuristic. Paradigm shifting and caution. There are real technical and operational risks. Engage the audience by posing rhetorical questions. What happens if communications are jammed? What if a swarm drone is captured or hacked? How do you protect the carrier itself? Let people imagine both the promise and the pitfalls. You can weave in a day in the future scenario. A carrier sails with no manned fighters, but hundreds of drones take off in swarms. Reconnoiter. A contested island strike targets return. Get refueled, rearmed, relaunched while a human crew monitors, intervenes when needed, but is spared frontline danger. You might also contrast the massive size and cost of a traditional carrier with the leaner footprint of a drone-centric ship. Show how the removal of human constraints could allow new architectures. Finally, leave viewers with open questions. What must be solved for this idea to become real? And when might we see the first full drone carriers? That encourages engagement and speculative thinking.